All right, here are solutions to perfect problem 2 for Math 243. The basic idea here is you are told that both IQ and height, we're going to assume those are approximately normally distributed. And you are told the mean average IQ is 100, and then given some statistics about what percentage of people fall in which range. And you're also told statistics about what percentage of people fall in certain height ranges as well. And what you'll see is this problem is all about what's called the empirical rule. The empirical rule, aka the 68, 95, 99.7 rule, is basically this picture up here. It tells you that if you're within one standard deviation of the mean, so assume all these tick marks are each represent one standard deviation. If you're within one standard deviation of the mean and the data is approximately normally distributed, then we expect 68% of the observations to fall within that range. And we expect 95% of observations to fall within two standard deviations of the mean, and 99.7, so damn near everybody, falls within three standard deviations of the mean. So that's kind of what I was getting at this picture here. And if you have that fact, I think you're able to answer all of these questions. So let's go ahead and get started. So number one, use the empirical rule, aka this thing, to determine the mean and standard deviation for both IQ and height. So for one, I'm going to introduce a little bit of notation. When we're talking about population mean, we use the Greek letter mu. But I'm going to have two different mu's in this problem. I'm going to have mu for IQ, and I'm going to have mu for height. So I'll put little subscripts on them. And then I'm also going to be interested in standard deviation. And again, when we're talking about population standard deviation, use the Greek letter sigma. So I got sigma for IQ, and I got sigma for height. And the claim is that in this opening paragraph, enough information is given to fill out all four of these. Then if you have all four of these, you can answer questions 2 and 3. So let's see what's in here. The mean IQ, well, that's given to you. The average American IQ is 100. Nice. Don't have to do any calculations for that one. Whoa, got a little weird. 100. What about the standard deviation of IQ? So that one you got to be a little bit clever about. You're told that 68% of people have an IQ between 80 and 120. So remember that 68% of people, 68% of observations are going to fall within one standard deviation of the mean because we're approximately normally distributed. So what that's saying is that 80 and 120 are the boundaries that signify one standard deviation within one standard deviation of the mean. In other words, 80 is one standard deviation below 100, and 120 is one standard deviation above 100. So essentially what that tells me is that a standard deviation is 20. Right? In order for this to be 1 below and this to be 1 above the number 100, standard deviation must be 20. Now we want to figure out the mean and the standard deviation for height. Those are a little bit trickier to figure out. What you're told about height is only 0.15% of adult males are taller than this amount, and only 0.15% of adult males presumably are shorter than this amount. So how can we figure out mean from that? Well, because our data is approximately normal, it's symmetric. And so if we have the same percentage of people above this amount as we have below this amount, then the average has to be halfway in between these two numbers. In other words, what I got to do is figure out what number is halfway between 79 and 61. And in order to figure that out, what I can do is take 79 and 61, add them up and divide by 2. Let's see, if I add those, I get 140. Divide by 2, you get 70. So that will be my mean height, is 70 inches. I'm going to leave units out of this thing. No, I'm not. 70 inches. Yeah, I'm going to leave them out. What about the standard deviation? Well, 0.15%. You don't recognize that from anywhere here in our empirical rule, but really it is part of the empirical rule, just kind of hidden. If 68% of the data is within one standard deviation, then the rest, in other words 32%, 100% minus 68%, is not within one standard deviation of the mean. In other words, this total area out here and this total area out here makes up 32%. And because my distribution is symmetric, half of that 32% is on this side. So that tells me that 16% is on this side. And that doesn't help me in this case because I'm looking for 0.15%, but I can do that exact same logic with this number up here in green. If 99.7% of the data falls within 3 standard deviations of the mean, so that's all this stuff in here, then the rest of it, in other words, the 0.3%, falls outside of that range. And so half of that 0.3% is on this side and half of that 0.3% is on this side. In other words, 0.15, half of 0.3, is out on this side. When you are told that 0.15% of adult males are taller than 79 inches, you immediately know that 79 inches is 3 standard deviations above the mean. And 61 inches is 3 standard deviations below the mean. And since the mean is 70, I can use either of those observations to figure out that 3 standard deviations must be equal to 9 inches. So if I divide both sides by 3, I get that the standard deviation of height must be equal to 3. And then you can kind of go back and double check to make sure this makes sense. If this is 70, then 73, 76, 79, okay, only 0.15 would be greater than 79 to the outside there. So I think that answers number 1, and I think that might be the hardest part of this question. I think once you got that down, you can kind of answer the rest of this stuff. Let's see. 2 says, using your answers to part 1, determine which is greater. Sketch distributions to support your answers. What we're going to be doing here is coming up with z-scores. So I want to know the proportion of adult males taller than me. I'm 6'3". 6'3", that's not very useful because everything down here is done in inches. But since a foot is 12 inches, 6 feet would be 72 inches. And 3 more inches would give me 75 inches. So I'm going to go ahead and convert that into a unit that's more useful. And I think later on we talk about KD, one of my favorite basketball players. And if he's 6'9", he's 6 inches taller than I am. And if I'm 75 inches tall, that would make him 81 inches tall. So I'll do that conversion real quick, and then I'll go back and answer these questions. 2A, I guess, says, which is greater, the proportion of adult males taller than Brian? So we got to figure out where I am in this distribution. So let's sketch height here. It's a decent bell-shaped curve. The middle for height is 70 inches, and standard deviations are each 3. So here's 73, and then here's 76, and 79. And as long as I'm here, I'll count down in standard deviations here. I got 67, 64, and 61. And so what I'm looking for is the proportion of people that are taller than 6'3", which we said was 75 inches. So that would be talking about, I don't know, somewhere in here. These are proportion of people taller than me. And if I do that exact same thing, I can get a picture of the people that have an IQ lower than Andy Warhol, some brilliant painter, so it's weird that he has a low IQ, but maybe that just shows how odd of a measure IQ is for real intelligence. Weird looking distribution. They're supposed to look the same, close enough. We know 100 goes in the middle here, and we know standard deviations go by 20. So this would be 80, and this would be 60, and this would be 40. And similarly, here's 120, 140, 160. And Andy Warhol was what? 86? So we're talking about somewhere in there. Lower IQ than Andy. And just from, I don't know, observation, it looks like there's more green over here than green over here. It's more likely that someone has an IQ lower than Andy. And I guess you could say just by looking at the picture, although I don't really like that answer because the picture was done, I mean, these are kind of weird looking pictures. It's hard to really tell. And to justify that, I could calculate z-scores. Maybe the z-score of Brian is a measure of how far above the standard deviation I am. How many standard deviations, I said that horribly, how many standard deviations above the mean I am. So I would take my observation, this 75, my height, and I would subtract off the mean, which was 70, and then I would divide by the standard deviation, which was 3. And if you do that, I think you'll get 1 2/3 or 1.67, something like that. And if you take the z-score for Andy, his observation was 86. And then we want to subtract the mean, which is 100, and divide by 20, which is the standard deviation. So that's what negative 14 divided by 20 is negative 0.7, because 1.67 is greater than positive 0.7. So I'm further away. I want to look at the absolute value of these numbers. And this one, 0.7, tells me that's closer into the mean than this 1.67. So that I know that the area outside this number is greater than the area outside that number. So that would be my answer to part A. And part B is almost identical, so maybe I'll go through it a little bit quicker. Wow, I don't know where I'll do it. I don't really have any room for it. I guess just in a different color. 2B, we talk about the probability that an adult male is shorter than, so here's 2B over here. 2B, similar picture. 2A, I ran out of room. The two z-scores, the z-score of Kevin Durant will be his height, which was 81, minus the average, which was 70, divided by the standard deviation, which is 3. So 11 thirds, in other words, 3 2/3, so 3.67. I think I did that right. And then I want the z-score of old Honest Abe, my cousin, or my cousin, distant cousin, I guess. My great-great-grandfather was Mordecai Lincoln, and his nephew, I think, was Abe. Anyways, Abe had an IQ, was estimated at 128, so I'll take 128, I'll subtract 100, divide by 20. 28 over 20 is, what, 1.04? 1.4? Yeah, 1.4. So what was I asked? Which is greater? The probability that an adult male is shorter than KD. Almost everybody's shorter than KD because he's way over here in the picture. And people that are less intelligent than Abe, well, 1.4 standard deviations. We're talking about somewhere in here. Most people, but not nearly as many as KD. So less. How about more likely? What did the question ask? Which is greater? Okay, so more likely that someone is shorter than KD. Based on these z-scores here. All right, and then there is one more question, and you'll want to draw some pictures. I mean, basically, you'll draw this exact same picture, except you'll put KD somewhere way out here, and you'll put Abe over here, and you'll shade this way for Abe, and you'll shade this way for KD. And then the last one, how tall would an adult male have to be to have his height be as impressive as the IQ of Leonardo da Vinci, whose IQ was 220? Okay. Da Vinci, D-A, D-I, D-I. Da Vinci, his IQ was, what, 6 standard deviations above the mean? Because if you take 220 and subtract 100, you get 120. And divide by 20, you'll get 6. 6 standard deviations above the mean. Uh, 6 standard deviations above the height mean is, well, let's see, the average height was 70, but then I want to add 6 of the standard deviations, which reach 3 inches. So 6 times 3 is 18. 18 plus 70 gives me 88 inches. What does that mean? Well, let's see, is 7 times 12 is 84. So 7 foot 4 inches is how tall somebody would have to be relatively as tall as Da Vinci was intelligent based on this measure. So not the greatest solutions here, but I guess if you wanted some help, hopefully this video talks you through everything, even if I didn't write everything very well up on this paper, because I kind of ran out of time. So on this here.